We can also apply rational exponents to variable expressions, and we can translate between the notation where we use radicals and the notation where we use rational exponents. So x to the 2/3, we'll typically write the notation where we put the exponent inside the root. So we'll say this is the third root of x to the second power. And in this case, that's as good as it gets, so we'll just leave it that way. X to the -3/2, well, that's going to be the square root of x to the -3. That's the square root of 1 over x to the third. All right, we want to use only positive integer exponents in our answer. That'll be the square root of 1 over the square root of x to the third. We'll leave this for now as 1 over the square root of x to the third. We will meet simplifying steps that we can do further, but for now we're going to leave that there. X to the -3/5, that's the fifth root of x to the -3. That's the fifth root of 1 over x to the third. So fifth root of 1 over fifth root of x to the third. 1 over the fifth root x to the third is where we're going to leave that for now. Now notice we did not rationalize any of these denominators, and that's because the instructions did not tell us to rationalize any of these denominators. We wanted to write it using radicals and positive integer exponents. That's what we've done, so we can stop here. Now, we can also, of course, apply the usual exponent rules to our rational exponents. We defined them the way that we did so that the usual exponent rules would continue to apply. So if we have expressions that combine various rational exponents, we can use, for example, the power of a product rule to say x to the 2/3 times y to the 3/4, all to the 3/5. Well, that's x to the 2/3 to the 3/5 times y to the 3/4 to the 3/5. And now the power of a power rule says that that's x to the power 2/3 times 3/5 times y to the power 3/4 times 3/5. Multiplying those fractions using a calculator if we'd like, we get that this is x to the 2/5, y to the 9/20. If we have x to the 1/3 times x to the 1/5 times x to the 1/2, that's going to be x to the power 1/3 plus 1/5 plus 1/2. Adding all of those fractions up, again using a calculator if we'd like, we get that this is x to the power 31/30. And finally, if we have x to the 1/2 y to the 2/3 over x to the 1/3 y to the 3/4, all to the -4/5 power, well, there are various ways we could work this out. I'm going to work out what's inside the parentheses first. So for my x's, 1/2 is greater than 1/3. So I'll have x to the power 1/2 minus 1/3 in my numerator. 3/4 is greater than 2/3. So I'll have y to the power 3/4 minus 2/3 in my denominator. And that's all going to be to the power -4/5. Working out that subtraction on a calculator if we'd like, we'll have x to the 1/6 in the numerator y to the power 1/12 in the denominator, and that whole thing is going to be to the power negative 4/5. And now I'm going to think negative exponent means take the reciprocal. So I'm going to take the reciprocal of what's in the parentheses. I'll instead have y to the 1/12 in the numerator, x to the 1/6 in the denominator, and that's going to be to the power positive 4/5. Applying that 4/5 power to my numerator and denominator, I'll have y to the 1/12 times 4/5 over x to the 1/6 times 4/5, which is going to give me y to the power 1/15 over x to the power 2/15. And that's what that simplifies to. So we're just applying our usual exponent rules. It's just that in applying these rules, we have to add, subtract, and multiply fractions.